Human-computer interaction teacher's note. Introduction. This set of teachers note accompanies the book Human-Computer Interaction and is intended to support teachers using the book as a core course text. It includes solution to and suggestion for the use of the exercise in the book, together with additional project material. In addition, a set of master slides of the available which can be used to produce overhead projector foils. These cover key points for each chapter, making them ideal for a lecture-based course. Please contact the publisher for further detail. We have tried to design the book and additional material to be flexible and support effective teacher of HCI. Obviously, in any such future venture, there is room for improvement. We therefore welcome comment on both the book and this set of notes, which will allow us to improve future edition. We are particularly keen to hear suggestions for material that you should find useful that we have not included, and conversely, to know if we have included anything which you do not find useful. Please send your comment to ask care of the publisher. Course structure. Human-computer interaction is subject which is definition practical and which lends itself well to novel teaching method. It is our intention that the book and this not be able to support traditional lecture style. Course and thus based mainly on project work. In either case, we strongly recommended that students be given the opportunity to do some practical work, but in experimenting with and evaluating existing available system and in designing their own interface. HCI cannot be taught exclusively through lecture and book and requires some hands-on experience. This is not over example of the type of project that can be used to provide such experience. As far as possible, we have not assumed the availability of any particular resource so that teacher can adapt them to what is available. However, if possible, we suggest that all students be given the chance to experiment with both graphical and command-based application and to use prototyping systems such as HyperCard and Visual Basic. This allows the student to develop their own mock-up interface. If such tools are unavailable, drawing packages can be used to design individual screens but have the disadvantage of being static. For a traditional lecture-based course, we suggest the use of the overhead projector slide, selectively, if necessary, backed up by related reading and exercise from the book and at least one practical design project. See additional project. If possible, other practical can be included as well. The design project should encourage the student to use the modeling approaches and to evaluate their design. A project-based course can be designed primarily around the exercise with the suggest recommended relating reading. Such a course demand and certain amount of commitment from students and may therefore be best suited for opinion course and other advanced course where the students are motivated toward HCI. Obviously, the choice of exercise and project will depend largely on the resource and time available, but the following is suggest programmer which assume 10 to hours practical and an individual or group project. In selection exercise, we have tried to include some that involve research, so that in involved observation and some that require practical application. Clearly, some of this can be done in student own time. If this is the case, the extra practice time can be spent introduce different interactive application and tool. At least one design project should be attempted depending on time. This can be done instead the exercise at the point suggest or an end of the project. In addition, project 2 and 3 provide most scope from incorporating different aspects of the course and additional results which we recommend to aid course design in is the CIG's Curriculum Development Group report. This provides suggestions for curricula for different groups of students and for different purposes. The book covers most of material outlined in the CG report and can be adapted for use with most and their suggested curricula, exercise, and project. The rest of this booklet contains solutions to exercise from the book and 3 additional design projects which can be used to bring together a technique from the different states of design. The exercises provided in the book are of 3 main types: those that require factual answer, some of which may require additional reading or research; those that provide practice in using the technique described; and those which encourage the student to observe and evaluate existing design. Consequently, the exercise solution also differ. For factual question, pointers are given to enable the teacher to guide and student in the right direction. However, students may in the process of their research uncover additional information on the subject, and this should be encouraged. In the case practical question, example solutions are given. Again, variation on this are sometimes possible. Individual solutions indicate this, but the solution given here can be provided to students as an example solution. Observation exercises are usually small practical projects which require the student to interact with an application or watch someone else do so. Here the solution suggests factors that the student should consider in the observation and hints to the teacher as to how to best encourage effective use of such exercise. Some exercises refer to section or diagram in the book itself, other to diagram internal to this note. The former are reference to using the same notation as the book. The latter are distinguished by use of the letter. Figure 12.1 refers to figure 12.1 in the book, while figure 12.x1 refers to figure in the note. The 3 additional projects are more extensive than any of the exercises and can be used as end-of-term project or assessment. They are not included in the book itself from the reason they require knowledge of more than one aspect of design and are intended to demonstrate how the different stages of design fit together. Each project is described in full, together with any support material, and hints to the teacher on how to use the project are given. This project can be reproduced for the purpose of teaching on course where the core text is human-computer interaction. Chapter 1, Human. Exercise 1.1 suggests idea for an interface which uses the property of sound effectively. Answer. This is an opportunity for the student both to use his or her imagination and or to do a literature survey starting with the reference in the chapter 5. One possibility for tackling the exercise is to encourage the student to think how should could be added to an application with which he is familiar. Speech sound can obviously be used to convey information. This is useful not only for the visually impaired but also for any application where the user attention has to be divided. For example, power plant control, flight control. Use of non-speech sound include attention to attract the user attention to a critical situation or to the end of the process. For example, status information. Continuous background sound can be used to convey status information. For example, monitoring the progress of the process without the need for visual attention. Confirmation. A sound associated with an action to confirm that the action has been carried. For example, associating a sound with deleting a file. Navigation. Using changing sound to indicate where the user is in a system. For example, what about the sound to support navigation in hypertext? Exercise 1.2. Device experiment to test the property of a short-term memory or long-term memory. Using the experiment described in this chapter to help you try out your experiment on your friend. Are your results consistent with the property described in this chapter? Answer. The, the aim of the exercise is to get the student to think about experiment design. The experiment device can effectively be repeats of the original. Chapters 11 can be used for reference on experiment design. Short-term memory (STM). The student should first choose an aspect to investigate. For example, digit span, recency effect, decay. Example solution STM decay. Subject ideally selected to represent population, more probably undergraduate student. Try to get a range of academic subject. Sample size 10 plus. Experiment. Split subject into two groups. Each subject studies list of 15 until 20 words. Could try with both nonsense word and actual word to see any difference. Subject has to recall list either A. Immediately or B. After 20-second delay. Measure the number or percentage of the word remembered correctly. A within group design can be used to avoid individual bias or group variation as long as different lists are used for each attempt. Independent variable, delay in recall. Dependent variable, number correctly recorded. Group B should be given to tasks to do during the delay period in order to avoid rehearsal. If possible, this task should copy a different channel to minimize interference. Visual recognition tasks. Hypothesis. Those in B will perform worse than those in A since STM will decay. Analysis. We have to see decay the test to long-term memory LTM. Students should first choose an aspect to investigate, for example, the total time hypothesis or the distribution of practice effect. Example solution, distribution of practice effect. Subject as above should have no prior experience of the skill to be learned. Experiment. Split subject into three groups. Each subject must learn a skill, for example, shorthand and or typing must be measurable. Group A learn for 1 hour a week for 6 weeks. Group B learn for 2 hour a week for 3 weeks. Group C learn for 3 hour a week for 2 weeks. After each group training is complete, the subject are tested and the number of mistakes made note. Independent variable style of learning, dependent variable accuracy. Between group design. Hypothesis. Group A will be best. Do the distribution of practice effect. Analysis ANOVA. And point B, this one is not easy to run but could be done with cooperation from friends. Exercise 1.3. Identify the goal and operators involved in the problem. Delete the second paragraph of the document on the word processor. Now, use the word processor to delete a paragraph and note your action. Goal and sub-goal. How well did they match your early description? Answer. Assume you have a document open and you are at some arbitrary position within it. You also need to decide which operators are available and what their precondition and result are. Based on imaginary word processor, we assume the following operator. You must wish to use your own WP package. Operator: delete paragraph, precondition, cursor at start of paragraph, result paragraph delete. Operator: move to the paragraph, precondition, cursor anywhere in document, result cursor, move to start to next paragraph except where there is no next paragraph when no effect. Move to start, cursor anywhere in document, cursor at the start of document. Goal: delete second paragraph in document. Looking at the operator of an obvious one to resolve this goal is delete paragraph which has the precondition cursor at the start paragraph. We therefore have a new sub-goal. Move to paragraph. The precondition is cursor anywhere in the document, which we can meet. But we want the second paragraph, so must initially be in the first. We set up the new sub-goal, move the start, with the precondition cursor anywhere in the document, and result cursor at the start of document. We can aptly move to the paragraph and finally delete paragraph. We assume some knowledge here that the second paragraph is paragraph after the first one. Exercise 1.4. Observe skill and notice operation in a familiar domain. For example, touch and hand and pick. Typist, expert and novice game players, or expert and novice user of a computer application. What difference can you discern between their behaviors? Answer. This is an exercise in observation. The student should think about skill acquisition, proceduralization, checking. Is there any evidence of this in practice? How do the group differ? Speed, error, style, strategy. Do the difference suggest different skill level? Exercise 1.5. Produce a semantic network of the main information in this chapter. Answer. The network is potentially huge, so it is probably unnecessary to devise to the whole thing. Encourage the student to be selective One helpful way to tackle the exercise is to approach it in both a top-down and a bottom-up manner. Top-down will give you a general overview of the topic and how they relate. Bottom-up can fill in the detail of the particular field. This can then be glued together to build up the whole picture. Perhaps a group of students could tackle the problem together, each taking one part of it. We will not provide the full network here, but will give example of the level of detail anticipated for the overview and the detailed version. In the overview, we have not included label on the art for clarity.